Hey guys, I thought I would make a complimentary optional video to explain a little bit more in depth about how linking works. Um, this is mostly important working in C++, but it's important to note that it's not really C++ dependent at all. It's sort of how it works in all of programming, really. How does programs get made and stuff like that. So it's really more of a, at an assembly level. But what's so nice about other languages is that they usually do all of this garbage for you. Like in C#, for example, you don't have to worry about linking library files or anything like that. The C#, compiler sort of has that baked into it. And it's just that C++ and C just doesn't have that. You have to you're expected to do that yourself. Which, has its pros and cons. But either way, it can be very confusing. So I thought I would make a little video for either those who are interested, because I think it is very interesting. Also good to know, as you guys are going to become programmers, probably some of you are going to become C++ programmers, I think this is very good to know in general. Might not permeate every single day of work for you, but it's always good to have this information at the back of your head, so you have a deeper knowledge about, the undersides of all of these things. I'm just gonna grab some water. There we go. I just had some hot cocoa before recording this, which is probably the worst thing to have before recording an audio speaking thing. Right. So I am gonna do this. Okay. All right, I'm gonna set up sort of a hypothetical situation, and I'm gonna remove as much of the details as I can, except for just the very important stuff. All right. So we're not gonna do C++. We're gonna do C because it's just simpler in this case. We're also not gonna use Visual Studio, the IDE. I'm just gonna use the command line tools because again, that makes everything takes away the details of how the IDE works and just looks at like what is linking, what is compiling. All right. So let's make a file here. I'm gonna call main C. And I'm gonna code in Notepad because that is my favorite IDE. Too bad I don't have a dark mode, but that's fine. So I'm gonna make a main function here. So main, we're gonna return 0 because we are good citizens. And let's just print hello C programmers. Like so. And let's also include stdio for printf. Great. So I'm gonna open up the command line here. Let's cd on into game. And let's compile this. So we use CL, which is a C language compiler, and we'll compile main C. Boom. Stuff happened, but it's okay because we have a main.exe here. So that's the final executable that we can run. So let's run it. Game.exe. Main.exe. There we go. Hello, C programmers. Nice, perfect. So it worked. What is this object file though? You see this? So when we compile, it didn't just turn the C code into just an exe. It also created this object file here. And that is because the C compiler, the way I use it right now, we jumped over one of the steps, or rather, one of the steps were baked into the compilation process, and it's called linking. All right. So if I just remove this for now, go back to before, and I'll do CL and then I'll do /C here. And what /C does is skips the linking. So I'm telling the compiler to be like, only compile, don't link. All right. So then I'll do main.c. And now we can see we only got this object file. All right. So, okay, what is an object file? Well, an object file contains the compiled code in assembly. or rather I should say it's not assembly, it's bytecode. So it contains a bytecode that's supposed to actually run on our CPU. So it contains that compiled code, but it also contains something called symbols. All right, so let's go into Paint here. Oh, just gonna take my little patty pad. All right, so what is a symbol? Well, in bytecode, there's really no such thing as a function or a variable. It's all just data. It's all just, you know, numbers, essentially, ones and zero, bleeps and bloops. And you know, that's fine. That's you know, that's how the CPU works. The CPU doesn't know anything about functions. It just want to run instructions. It's like, give me an instruction, I'm gonna run it. But for us humans, we like to map those bleeps and bloops, those data out, into some sort of naming convention, I suppose. So we want to say, like, if we have the bleeps and bloops here, it's just a bunch of data. It's like these numbers. And we want to say, hey, this number here, that's the start of a function. We want to say that, for example. That's the start of the function main. Oops. Oh, there we go. So we're saying, hey, this specific bleep at the beginning of this line and bleep and bloops, that's the start of function main, all right? And a C compiler is the one that sort of produces these symbols for us. It's compiling our function main. There it is. It's compiling our function main. It's compiling our function main. Stumbling on my words here. Into a bytecode, into use bleep and bloops, and then it's saying, hey, the beginning here, the first bleep, that's main. And the same is true for stuff like variables. Global variables will have symbols. So, you know, our little, like, here is our, you know, I don't know, player health or something. Whatever sort of variables we have. Or maybe it's just like some string, for example. Like if I make yeah, exactly. This hello C programmers, for example. That string has to be an object file somewhere, right? Because we have to pass it into the printf function. So that's somewhere in this massive array of bleeps and bloops. Somewhere in there is that string. So here's that, you know, printf string. I'm just going to write that. Printf string. So, you know, that's somewhere in there. And that also has a symbol attached to it because it is technically a global variable. I won't get into, like, you know, C string semantics or anything. But what I'm trying to say is that symbols give names to particular pieces of data in just the bytecode, all right? Great. So that's what symbols are. And let's actually take a look inside of the object file here, because we have a nice, neat little command line tool called dump bin. So I'm just gonna dump bin the main.object. Again, dump bin, you know, you won't use this when you're compiling, obviously, in Visual Studio. You won't use any of this. This is just to sort of show you guys a little bit, take a peek under the hood. So don't worry about, you know, remembering exactly dump bin or remembering anything like that. This is just a tool to show you guys these things. So dump bin, you know, it's done some stuff, but we want the symbols, okay? So I'm just gonna do dump bin symbols. Whoa, okay. So it has a bunch of symbols, all right? Because the C compiler is actually still quite complicated. It has a lot of stuff defined in even though our main file was very small, there's still a bunch of stuff being, you know, sort of put into it when we compile. So, you know, all of this garbage, yeah, I don't really care. The things I'm sort of caring about is here. Here's main, all right? So that means somewhere in this object file, in section 3, main is defined, all right? So the data for main, the actual instructions to run on the CPU, is defined in this object file. Is it defined in section 3? And, you know, don't have to worry about what sections are. The only thing I care about is that it is a section, all right? So section 3 main. Great. Cool, but, you know. Oh yeah, and I should also show, of course, to get this from an object file to an actual exe that we can run, I run the link. All right, so I'm looking at link main.object. So link is another tool to turn object files into exe files. Doesn't really seem necessary now since we only have one object file, but later on it's going to become a little bit more clear why this is the way it is. And there we go, so link main object, and now we can see we have this main.exe here that I can run. Whoops. And there it is. Hello, C programmers. All right, a lot to take in, and again, I don't want you to remember this because it's not going to be a test about how linking works. I just want to tell you guys so you sort of have heard it once, maybe store it somewhere in the back of your brain. You have something called symbols, and there's something called linking, you know. It's okay if you only retain a sort of surface level knowledge about this and don't remember much of the specifics. That's totally fine. Great. So what happens if we do use more than one file? What happens then? So let's say we have a function declaration here. So I'm just gonna do int secret number. All right, so here I'm declaring a function, but I'm not defining it, all right? So in C++, there's a very specific difference between those two statements. Defining a function means you're writing the code that's associated with that function, right? So for example, in int main, we're defining main. We're saying int main is doing these things, these instructions. When declaring a function, you're saying there is a function called secret number, but we don't know what it does yet, all right? But we're sort of telling C++ that I know there's a function called secret number. So, and if C++ knows, okay, somewhere there is a function called secret number, we can call that. So we can do, oops, printf secret number d secret number. And again, if you're not super high on printf and, you know, format specifiers, that's fine. Doesn't matter. You can just see this as I'm printing the result of secret number, all right? That's all you need to know. All right, so this looks good. Alarm bells should be ringing right now because we're calling a function that does not have a body, right? So there's something should go wrong, right? So, you know, let's compile and see what happens. And I want you guys to guess what's going to happen. Sort of make a guess for yourself in your head or say it out loud or something. What's going to happen when I compile here? What error am I going to get? And I didn't get any error. So it actually compiled just fine. So it was a trick question. So, okay. We compiled and that worked. Let's check out the object file to see what's happening there. So I'm gonna dump bin main.object. Oh, I want symbols. Let's see. All right. So here's main. Again, all of this garbage, you don't care. Here's main. That's defined in section 3. So we have the symbol main, and it's you can see it as pointing to an address in this object file. If you were going with the bleep and bloop analogy. And here's secret number. So okay, so the symbol is in there. But here's the important part. If you look at this section here, it says undefined, undef. And what that means is that the object file is saying, I'm referencing secret number. So, either a function is calling it, or, what have you. Doesn't matter exactly how that works. What's important is that this object file is using secret number, but it's saying, however, I don't know what it is. It is not defined in this object file. There's no pointer to a bleep and bloop that's tied to that secret number. While with main, I'm saying like, oh, here's main. It's right here. Here's main. So let's write this down, okay? So I'm gonna go here. So we had main. We had main.c, and that gets compiled into main.obj. Okay, and main.obj contains the symbols main. That's the function. And it also contains the symbol secret number. Whoops. However, secret number is not defined in main.object, so I'm going to write a question mark for that. All right. So what happens now if we try to link this, right? So let's do link into main.exe. Let's try it. That's the wrong. There we go. So I'm gonna link main.object. Okay, and here we get an error. Okay, so now it has detected that we're doing something kind of weird. It's saying main.object, unresolved external symbol secret number referenced in function main. So it's a linker error. It's not a compile error, it's a linker error. And you can see that by this LNK 2019 error code specifying that, okay, it compiled just fine, nothing wrong with their C code. It's actually later on when resolving symbols that something goes wrong. And here's where it's sort of detecting that, hey, you're referencing the secret number that you don't even know what it is. You don't know what it's defined to. That's illegal. You can't do that. So it refuses to make the exe file. So how do we solve this? Well, obviously we could just define secret number in main.c, but that will end up having, one gigantic main.c file that's, would be quite unwieldy to use. And we're fucking programmers. We're cool. So instead, I'm gonna make a new file. I'm gonna make number.c. There we go. Open up another notepad. And in number.c, I am gonna define secret number. So I'm not gonna declare it. I'm gonna define it. Well, okay, by defining it, I am also declaring it, but you get what I mean. Whoops. And we're gonna return 5. That's gonna be our secret number. So, big difference. In main.c, I am declaring secret number. In number.c, I am defining secret number, okay? That's the big difference between these two files. So, when I go into the command line, I will compile secret.c. Oh, number.c, whoops. There we go. Okay, so number.c is now compiled. Let's look at the object file, because now we have a number.object file being produced by the compiler. So I will dump in symbols. Number.object. Alright, so way fewer symbols, that's cool. Again, a bunch of garbage we don't care about. This one I do care about. Here it's defining the symbol secret number. And we can see the section here, it's not undef, it's actually section 3. So this object file is saying, hey, I have this simple secret number, and I know what address that has. I know which bleep and bloop is a secret number. It's defined in this object file. So what does this mean? So I will do number.c gets compiled into number.object. And number.object is defining secret number. So that's, there we go. So so the next step is the linker, okay? So now when we link, we're not just gonna put in object or main.object or number.object. We're actually gonna input both. We're gonna say, hey, take these two object files and make an exe. Okay, let's actually do that first. So we'll do link main.object and number.object. And now it worked. Now we didn't get a linker error, it made the exe. So if I call main.exe, there we go, secret number is 5. So that seems good. Also, I'll say the main.exe just takes the first object file and makes that the name of the exe. So what did the linker do? What happened? What was different this time? Well, the linker took all of the object files and looked at them at the same time. And went one at a time and went, okay, main.object, okay, secret number, you don't have that one. You want to know what address that is gonna point to, and then it looks in the numbered object and says, okay, it's defined here, so I will resolve this undefined symbol to point to this function here. So now we resolved the symbol. It was undefined before, but now it has been resolved, and we can sort of link these two together. So that's why now we did not get a linker error, because our unresolved symbol has been resolved in another object file. Cool. Great. And yeah. So that's cool. And this is what's happening in Visual Studio when you have a bunch of C file or C++ file rather files, and you hit F6 or whatever button you have to compile everything. This is actually what is happening under the hood. It's taking each file and compiling it down into an object file, then linking them together into the exe, and it sort of does that in one swoop, I suppose. So what I did now on the command line is just exactly what is happening in Visual Studio. We're just taking the steps one at a time. Cool, okay. So how can we take this further? What if I want to have a super secret number? Okay. So I'm gonna say super secret number is something. All right, I'm gonna call it. And let's just do what we do. We'll compile it. So we'll compile main.c. I will link it. So main.object and number.object. Whoops. And again, I want you guys to guess what's gonna happen when I hit enter. We get an unresolved external symbol, all right? Which is what we expect, because now we have let's see. Move this down a little bit. Like that. Now we have this new symbol called super secret number that is undefined. And you know, number.c, it does define a secret number, but it does not define a super secret number. So again, we have this dangling symbol, this unresolved symbol. So it refuses to make the exe file. But let's say, you know, we're pretty good at programming. I would say we're pretty cool, but we are not good enough. Let's say we're not good enough to make a super secret number. You know, secret numbers, we can handle that. That's rookie stuff. But super secret number, that's way too hard. So, you know, we post on the message board on, you know, the Hacker Society and say like, hey, does any one of you know the super secret number? And then one little hacker tells us, oh yeah, I know that one. I'll send you a lib file. And we're like, what's a lib file? What's that? And he says like, well, this is the library that all hackers use to, you know, get all the secrets that are out there. So he sends us this hacker lib here. Okay. Okay, well, here's lib. So here's the hacker lib library file. So cool. Let's take this and put it in our folder. So I'll take it here, put it in the game folder. And he told me that in this library file is defined super secret number. So we trust him. So we'll use link it then. So main object, number object, and hackerlib.lib. Okay, so we'll link all of these three together and see what happens. Ah, it does. It works. So we got our exe file. So let's just write out here what happened. We got our hackerlib. Oops. .lib. Whoops. Bill. Lib. And in the hacker library, it's already defined super secret number. All right, so that's defined. So libraries are not very different from object files. They are very similar. Two libraries have bytecode that's, you know, pre-compiled. So some hacker out there compiled some C code or C++ or, you know, Python or whatever they compiled into a library file with the bytecode, and in there was also the symbol super secret number. So when our linker links these three files together, it will find that this super secret number that was previously undefined, it can now resolve into this this compiled bytecode inside of the library file. Cool. So all our linker issues just magically went away. And just to, you know, be safe, let's actually check out what the super secret number is. And if I call the main.exe file, it's 20. Okay, should have known. So now we're using a library to get our super secret number. So why do this? Well, in our example, it's kind of dumb. It's just like a function returning an int. But, you know, in the real world, a library would contain, you know, thousands of functions from thousands of files, perhaps, that gets compiled into one convenient file that we can just include in our project, or link with a project, I should say. So you should see a library as just a big collection of code and symbols to point to that code. The other way to do this would be maybe they provide us with the source code to the hackerlib, and then we would have to, you know, compile every file with the C or C++ compiler or whatever it is, and then, you know, gets thousands of object files. So we have to link all those thousands of object files into our linker, and, you know, we could do that. We could totally do that, but it's much more convenient to have just one library file that already does that all for us. So we just skip over the compile step. Great. Let's actually look inside the library file. I don't know. I'm curious. Does it actually look very similar to the object file? So I'm going to dump in symbols this hacker lib. And okay, here's super secret number. Great, so it's defined here. What's this? Number only for elite hackers. They didn't tell me about this. Maybe this is a test. Maybe this is actually... They didn't think we were ready. But we're ready. Number only for elite hackers. Yeah, let's do that. But what kind of function is it? You know, does it return an int? Like, how do we declare this function? We don't know. Well, don't tell anyone, but I actually hacked into... Oh, excuse me. I hacked into the Hacker Society mainframe, and I got the include files. Look at that. Let's check it out. Aha, there it is. Okay, so it's in there. We are confirmed that it is in there. Okay, so, and there's super secret number. So, you know, we could declare this like we've done before in our main file. We could declare the function like int number only for elite hackers, you know. But, you know, what if it changes? What if there's thousands of functions in this hacker library, or, you know, whatever actual real library we are using? It would be a pain in the ass to have to declare each and every function to be able to call it, and you know, they might be very complicated. So instead, I'm just gonna use this nice convenient include file that I hacked from the Hacker Society mainframe. So let's include it. So I'm gonna include hackerlib.h. All right. Let's compile. Oh, can I open include file hackerlib.h? So that sucks. How do I fix this? Well, the C compiler the C compiler does a few things when we include. First of all, it checks the local directory. So it checks like, okay, this file that you're trying to include, is it, you know, in the same folder as the C file? So it checks the local first, and then it will check the C standard library, C standard include folder, where stuff like stdio, stdlib, you know, iostream, windows.h, all those files are in. It will check those folders. And then if it doesn't find hackerlib.h in any of those, it will give an error to say like, oh, I couldn't find this. But we can tell the C compiler to also search this additional directory to say like, hey, we have this other library and it has a bunch of header files and it's in this directory, so check that as well. So in Visual Studio, you would go into project properties and then additional include files. Or sorry, additional include directories. And that will tell the compiler to be like, oh, whoops, we have additional include files here. We're going to do in the command line. Again, this doesn't really matter exactly how we do it. It's the capital I. So then slash capital I, and then I'll just type in the path. So it's going to be prog, and then it's... where is it actually? Prog linking hackerlib include. Okay. Again, the specifics are not important. I'm just trying to give some context to what we did last lesson, where we did the additional include directories in Visual Studio. Whoops. In there, you know, we copied the includes into a separate folder. Doesn't really matter. We could have done this as well. We could have provided the absolute path to the include file in the library. All right, so now we told the C compiler that we had this additional include directory to search through. I'm also going to do C for compile only, don't link. And now if I compile the main file, okay, there we go. So it compiles. So we additionally, we've successfully included the hackerlib header file. And now I can call it. So I'm going to call number only for elite hackers. Number only for elite hackers. Excuse me. Oh dear. Let's link it. This we will link. Oh, sorry, no, I added. I'm gonna compile again. There we go. So now compile actually calling the delete hackers function, and now we will link it. So we'll link main.object, and then also number.object, and hackerlib.lib. And there we go, everything linked together. Since this number only for delete hackers was already defined in hackerlib.lib, you know, we didn't need to change anything there. It was already there. We just had to call it and get sort of the declaration going. So let's call it and see what happens. Number only for delete hackers is 420, baby. We're hackers. We're lead hackers. It's official. This was actually the test to become a hacker, so congratulations. We all made a test. So you can now call yourself officially a hacker. So that's cool. We're gonna take a little brief break to just get some tea, and then we're gonna look at something called dynamic linking. I'm back. All right. So now we've seen looking. We've seen. Wish I could start over. Okay, so now we've seen linking object files and library files, right? And I'm gonna give you the name for this. All of this is called. I have way too much on my desk. Hold on. Giving you guys some suspense. What possibly could this be called? This is called static linking. So say, whoops. Static linking. And static linking means that all the code for the program will all be compressed into the exe file. All right. Compressed seems like it's getting not compressed. I shouldn't say that. I should say combined. It's all the code gets combined into the exe file. So code gets combined into the .exe file. There we go. And you know, this is very convenient because if I want to send my game, for example, to a friend, or I want to distribute it, I only need to give them the exe file. You know, I can put this exe file anywhere and it will still run. So if I, you know, put it in this directory here instead, oops, it still runs just fine. So all the code that's required to run this is in this exe file. Cool. I fucked up somewhere. All right. But now we're going to look at something called dynamic linking. All right. And dynamic linking is another kind of linking. So this is it. Dynamic linking. Oops. And dynamic linking means some code is loaded. Oops. There we go. Loaded after the program starts. After the program starts. There we go. Okay, so how is this done? This is done via something called DLLs, okay? .dlls. And DLL stands for Dynamic Linked Library, or Dynamically Linked Library. Actually, I don't know exactly what word that is, but it's dynamic. So if we go into something called message lib here, so that's another library that we're gonna use in our little game. It's a little library provided to us to, you know, print some nice messages, which we want to do. So we downloaded this message lib from the internet, let's say, and for whatever reason, the authors of this library has decided to distribute the library as a dynamically linked library. So it has a DLL here, so a message lib.dll. It also has a library file though, so that's kind of strange. Why is that? So you know, we're gonna get into that in a second, but before that, let's just, you know, implement this library in our little game. So I'm gonna copy the DLL. Actually, let's not do that yet. Let's actually only copy the library file here. You see what happens then. And it has an include folder with the message label H. Let's check that out. Okay, so it's just one function, and it's just, you know, print superscript message. Excuse me, I got a message. I'm just gonna close that. So it only has one function, print superscript message. So that's cool. So let's include it in our game then. Oh, we have a lot of stuff open right now. Let's just close some of that down. So I am gonna include messagelib.h. And again, I'm gonna have to add this as a, let's see, cl c main.c. Okay, so I'm gonna have to include both hackerlib and this message lib. So I'm gonna add both of those include directories to our include search paths. So I'm just gonna do CLI big I. Actually, let me just up arrow until we find it. There it is. So I'm gonna CL big I, d prog linking blah 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 blah, and I'm also gonna do d prog linking message lib include. All right, so now I've added both the hacker lib and the message lib to our include search paths. So now hopefully when I compile it, there we go. So now we compiled. So now we have this message lib.h, and it had the print secret message function inside of it. See if that compiles. Yes, it does. So now we're calling this print secret message. So let's link. So I will link main.object, number.object, hackerlib.lib. And okay, so we still get this print secret message, unresolved external symbol. So it still needs to be resolved, this function, even though it's going to be loaded dynamically. It still needs to be, the actual function call needs to be resolved. So okay, fine. I will also link this this message lib library then. So I will link this message lib.lib. Message lib.lib. That's not good. Still getting an unresolved external symbol. What did I do wrong? Let's check the dump in here. Message lib.lib. Let's check it out. What do we have? Doesn't seem to have a function here. I must have done something wrong when I made this library and DLL file. So I'm just gonna pause and see for a sec what I did wrong here. Okay, there sounds I'm a big dumb. Okay, so if I would have actually looked at the header file, let's take a look at it. It says print super secret message, and I just typed print secret message, And this is a C thing that I hate, which is that if you are calling a function, if you're calling a function that you have not declared anywhere, it will assume it's an external returning int. All right, so it will sort of auto-declare that for you. Whereas if this was C++, it will give me a compile error saying that it doesn't know of any function called print secret message. So that's what I did wrong. I should have looked at the header first. So it's just going to do print super secret message. Okay. And now if we compile like that and link it, there we go. Now we didn't get a linker error. Okay, so this print super secret message is declared. Okay, and it's defined in the library file. So what happens when we run now? So I'm just going to do main.exe. And nothing happens, okay? So it didn't even run anything. It didn't run the hello C programmers or any of the other stuff. And why is that? Well, it's because the library file, rather than containing the code for the actual function, so rather than containing code for like what does print super secret message do, it contains code to load the DLL file. All right. So what's happening is that when we are calling print super secret message, instead of calling the code in the library file, it has sort of loaded the DLL file and loaded the code that's inside of the DLL file, and then instead calls that. All right. So when main.exe is starting, it's actually loading all of the DLL files that it needs. You know, this is kind of complicated how exactly loading of DLL files works. It's it's platform independent, so it depends on if you're using Windows or Linux or Mac. So it's how loading DLL files is actually implemented is kind of irrelevant in my opinion. The most important thing is that it needs to be loaded at some point when running the game. But important to note that it actually just compiled and linked just fine. Nothing happened there because we're sort of saying like the function is in the DLL file, it's going to be loaded later. And it's actually when we're running that it fails. And what's happening for in Windows case, when you're trying to run an exe file that's dependent on a DLL and the DLL doesn't exist, it just fails. It just doesn't run the game at all. And I think maybe if we run it not through the command line, if we just run it here, yeah, there we go, we actually get an error as well saying the code execution cannot proceed because messagelib.dll was not found. And then it says like restarting the program may fix this problem. All right, so here's where the DLL comes in. It's complaining that it cannot find the DLL, so we'll provide the DLL. So I'll just take this messagelib.dll and just put it in here. By default, DLLs are loaded in the same folder as the exe file, so it's expecting DLLs to be where the exe is. That's why most times, if you're looking at games or programs or stuff like that, there will be a big folder with the exe and hundreds of DLL files, which is just all the code that it's using. So now if we run, there we go. Now it works, and it turns out this is the secret message. This is a secret message poo poo pee pee. So that's good. And again, I just pasted the DLL file in the folder. I didn't, have to recompile or do anything at all, really. All I had to do was just paste it in there and just run the game again, and then it worked. So that's, confirming that the code is loaded when we run the game. So why do this? What's the point? Well, I mean, there's no better or worse way to do linking. Both versions have, or both static and dynamic linking have their pros and cons. The pros of static linking is that you get all the code in an exe file, very convenient, and it's quite easy to do. It's it's very simple to do library static linking. You don't have to do, link to lib and also, we include a DLL file, and you have to make sure the DLL file is with the exe and you copy it over and everything. But the upside of the DLL files is that, first of all, your exe becomes smaller because the code is not in there. But of course, you have to include a DLL, so it's still gonna be, there's still gonna be that code has to be somewhere. But what's nice about DLLs is that, there are some code that is sort of expected from all programs to use. Like, the kernel is one example where, calling printf, for example, is, a kernel call. It needs to handle how the console writes stuff, and that code has to be somewhere. And, Windows is another example. Opening Windows, pretty much all programs are opening Windows and, displaying message boxes or whatever. So instead of including all of that code, like, it's so much code into every single exe file, which would happen if we would statically link all of that code. Instead, Windows provides the DLLs, and then they say, hey, we have a bunch of DLLs, you guys can all just reuse these DLL files. So what happens is that when you are, have a game that wants to open up a window, what you're saying is that, hey, I want to dynamically link with Windows user32.dll file, which is, installed on your computer. And then, all games and all programs will just use that DLL file. So you're saving on a lot of space by not having to include that in every single exe file. You can just reuse that code. Excuse me. So that's one big upside of DLL files, is that sharing code between programs is a lot easier. Another very big, very important upside of DLL files is that you can change code without changing the program at all. Let me give you an example. In this message lib library that we were using, they released a patch. All right, so here's message lib patch. And they're saying, hey, we have updated the code. So, okay, great. And if this was a static library, we would have to, download the library files and then relink everything, all right, to put the new code inside of our exe, because we're using static linking. But since this message lib was distributed using DLLs, all we have to do is just take this new DLL file and just replace our old one. So this DLL, I'm just going to remove that one and replace it with this patched version. Like that. And I don't have to do any new linking. I don't have to do anything more. I can just rerun the program and let's see what happens. Okay, there we go. Our last message was very immature. We apologize. Great. Press any key to continue. Oh no, message. Okay, that's a bit rude. So the code completely changed in the new DLL. Not only did it do new things, not only did it print a new message, the functionality was completely different as well. It opened up a window. It didn't do that before. So the strength of DLLs is it's very easy to swap out code in programs by just swapping the DLLs. And this is very important for stuff like drivers. All right, the graphics drivers on your PCs, your graphics card, they can change once a week, once a month, or so on. And imagine if all the driver code to interact with your graphics card had to be statically linked. That means every single game developer that ever releases a game has to update their game to statically link this new driver code and redistribute the game. So if I just didn't do that, then my game would run forever on old drivers, because I it wasn't bothered to re-statically link the new graphics drivers. This would be immensely annoying and very dangerous and unsafe. So the way that graphics card manufacturers has solved this is to say, you install graphics drivers on your computer, and that comes with DLL files that contains the actual driver code. And then what you tell game developers is saying, hey, dynamic link with these DLLs, and you will get the drivers. All right. Of course, the games don't do that directly. They use OpenGL or DirectX, and in turn, those libraries link with the drivers. I mean, that's what actually is happening. But for simplicity's sake, let's say we as game developers directly link dynamically with the drivers. That means as long as all the function calls stay the same, they can just swap out the DLL. So a new graphics card update comes. There's new drivers. We download the new drivers. Those DLLs all gets swapped out. So when I relaunch the game, they're gonna be using the new driver because they're just gonna load whatever code is on the DLL. And this gives a lot of power to the driver makers to make sure that they can have freedom with changing up their drivers without having to worry about it not being implemented in all the games. Of course, this has the downside of they can't change function calls, because if they change function calls, then that's not gonna match up with the exe anymore. So when they try to load DLL function from the DLL, they might not match. Maybe the return value has changed, or argument is not the same anymore, and then garbage will happen. And also it means that if a game is using old drivers and it doesn't get updated, eventually they're gonna have to change some major stuff. They're gonna have to small changes will combine into a very big change, and all of a sudden all those old games won't work anymore because they're dynamically linking with old drivers that don't exist anymore. So games will stop working. Whereas if all of them statically linked, then maybe they would have survived for longer because all the driver code is in the exe. So that code won't change. It will just stay the same. But that's how it works. That's DLLs. A bit more complicated, but they have a very specific use. Yeah, and I think that's it. That's all you need to know, I think. For at least surface level stuff. So thank you guys for watching, and see you next time.